In this video, I want to talk about difference equations and how difference equations kind of represent the processing that is going on um, in the digital domain. Okay, so we've already looked at how signals are represented in the digital domain, right? So if we have a signal X, now this signal can be written as an indexed variable. So what we mean by that is that the values of X are stored in an array, right? And various locations of this array have an index associated with them. So 0, 1, 2, 3, 4, 5, 6, and so on. Okay, and we can access any particular element of that array by referring to the index of it. So if I write x3, what I'm referring to is the value that is stored here in the third location of the array, and similarly for other indexes as well. Okay, so we have also said that the way to get to way to process signals in the digital domain is to take these various values stored in the array and combine them in some fashion. Okay, so basically what I'm saying is that the output at any point n can be equal to a summation of different signals where m could go from minus infinity to infinity. Okay, so basically you take all the signals. Well, give me a moment. I don't think there will be minus infinity here. Let's write 0 here. I think that would be much more easier to deal with. So the output at that point could depend on the input at that point and all the subsequent inputs. But it could also depend on the previous, sorry, it would depend on that signal and all the previous inputs. So that's why I'm writing it n minus m. And m goes from 0 to infinity, which means all the previous inputs, if as long from the time the signal has started. The output could depend on all the previous inputs. You don't want the output to depend on the future inputs, which you would start getting if you put m as negative. Okay, so let's leave it like that. Now this equation is a difference equation. Okay, difference equation is the discrete or the digital equivalent of differential equations which we had in continuous time domain. So all transformations in the digital domain can be represented as different difference equations. Now you now, in addition to just adding up values, what we can do is we can do weighted sums of values. So we can have another term here called AM. And these AMs actually are weights that we can take and we can add numbers. So let's just take a few examples to help you see what I mean. So you can have yn equal to, let's make it a very easy kind of equation. So it's xn plus xn minus 1. Okay, so what kind of processing is this? So what we are saying is we already have an array called x here, right? So what we are going to do is let's create an array called y. Okay, let's make an array called y here. Okay, this is y, and we have the same indexes 4, 5, 6, and the value, let's say at 2, is what? Y2, y, let's say n equal to 2, so y2 equal to x2 plus xn minus 1, that is 2 minus 1, so x1. So we're going to take the value here and the value here, and we are going to add them up and store that in y2. Okay, you could do other kinds of processing as well, right? You could say yn equal to xn, let's say 1 over 3 xn plus 2 over 3 xn minus 1. Now let's write this, let's see what does this do. So let's say I want to figure out what goes in instead of y5. So what do? I take this value x5 and I multiply it with 1 by 3. I take this value x4 and multiply it with 2 over 3, and then I add them up and store them in y. So that becomes y5. And just like you calculated y5, you can calculate y4, y3, y2, y1, y0, and so on, or, uh, through to infinity, right? So what we are basically doing is we are taking these inputs and we are combining, doing weighted sums of the inputs and doing some kind of processing. Now, what this does and why and how you would decide um, the weights and which uh, terms to combine is a question that we still have to answer, and we'll discuss that in the subsequent lecture.